What's going on, everyone? Let's talk about working with piecewise functions, okay? So piecewise functions, just like example 1 and 2 that we'll go over together here, is basically a function, f of x, that's defined by the function basically corresponding to different equations on different portions of your interval. So in this case, for number 1, this function is a single function, f of x, that really corresponds to ax squared minus b. Think of this on the left-hand side of x is equal to 2, right? So x is less than or equal to 2, right? Once you hit 2 and you get to the right-hand side of 2, I'm not sure what side of the screen you're on, then f of x follows this equation, 3x plus 1. And say your task is to determine values of a and b that make these two equations, continuous and differentiable, okay? And so I'm going to underline continuous and differentiable because we need to make sure to account for these two things, all right? And this is a two-step process, really, or three-step. And so step 1 is we're going to consider continuity in step 1. And how we're going to do this is if you consider this first equation, right? Let's call this f1 of x, and let's call the second one f sub 2 of x, right? And same thing over here, f1 of x, and this is f2 of x. Conceptually, the first thing you're going to do is you want to set these two, f1 of x and f2 of x, equal to one another, okay? f1 of x, you want to set them equal to each other, and you actually want to assess both of these. You want to plug in, right, the target value of x. When you look over here, right, notice that this value and this value are the same, right? Because f of x is defined by this function on the left-hand side of x is equal to 2. And this function is how f of x is defined on the right-hand side of 2, right? Greater than 2. And so you want to set the two functions equal to each other, but more so, you want to also plug in that value, right? So you want to evaluate both of these at x is equal to 2. So this is going to be step 1 if we're talking about number 1 over here, right? And you're going to get an equation, right? That'll be your first equation. But in here, remember, we're solving or determining values for two variables. So to determine two variables, we need two equations, okay? The second equation is going to come from step 2 right here. This is where we will consider differentiability, or making sure it's differentiable, okay? And so to do that, very similarly, instead of setting the functions equal to one another, we're going to set their derivatives equal to one another. So the derivative of f1x, right? We're going to set that equal to the derivative with respect to x, right, of f2 of x. And just like you did here, we're considering the target value of x, which in this case is x is equal to 2. So instead of just doing this, you're actually going to take the derivative and plug in x is equal to 2. So we're going to plug in x is equal to 2, okay? And so far, if you're following, right, we have already done step 1, where we set the functions equal to one another and plug in our x is equal to 2 in this case. And step 2 is to set the derivatives of both of those functions equal to each other and plugging in x is equal to 2, right, our target x value. Once you do these two steps, you're going to have two equations that you can use in order to solve for a and b. So let's work in context and see if we can understand this a little bit better, okay? So again, in number 1, we have f of x, which is defined by these two functions over these intervals. And so let's do this. Let's determine a and b. So first, let's consider continuity, okay? So for continuity, we are going to, and this is step 1, we're going to set these functions equal to one another. So we have ax squared minus b is equal to 3x plus 1, okay? We'll do this first just so we get the concept down. Now we're going to plug in our value, right? In this case, our target value is x is equal to 2, okay? And so let's plug in 2. So 2 squared is 4. So 4a minus b is equal to 2 times 3. Sorry, 3 times 2. which is 6 plus 1. That's going to give us 7 on this side. So we get this. And notice that A and B are in this first equation, right? You're not going to be able to find the values with one of these equations alone. That's why we need our second one, okay? So let's simplify this one down. So let's just say B is equal to, we'll move this over, 4A minus 7, okay? So we have one equation for now. We need our second one, okay? Now, step 2, and I'll circle these so it doesn't get lost in the work. Step 2, let's consider being differentiable. Now we need to set the derivatives of each of these equal to one another, okay? And so I'll even write it this way, d dx of ax squared minus b, that's our first function. Let's set that equal to d dx of our second one, 3x plus 1, okay? The derivative, you apply it to every term in your expression. So the derivative of ax squared is 2 times a x, right? Because a is a constant, right? It's like a number. You can treat it like a number. So 2 times a is 2a. Leave our value here and subtract 1, and you get 1. Okay? Minus the derivative of b. B is a constant, and so the derivative of a constant is always 0. Okay? So I'm not going to put that in there. That's the left-hand side. The derivative of 3x is 3, according to our power rule, right? So 1 times 3 is 3. X, leave it there, and 1 minus 1 is 0. Anything raised to the 0 is 1. So this is just 3. Plus the derivative of 1, which is a constant, is 0. So now we can plug in x is equal to 2, right? So 2 times 2 is 4. So now you have 4a is equal to 3. And now you can solve for a. So a ends up being 3/4, right? We have one of our values. Now we can take 3/4 and plug it back into our first equation and solve for b. So now you have b is equal to 4 times a, which we just found out is 3/4 minus 7. This turns out being 3 minus 7. So b ends up being -4. Okay? And there you go. You found a, you found b. Let's do it one more time in here, and feel free to pause the video and try it yourself if you'd like. Okay? So again, we have two equations, 1, 2, defined over different parts of our interval. And so step 1, let's consider continuity, right? We're going to set the functions equal to one another. So let's do that. b minus ax squared is equal to 1 minus 2x, right? Now we can plug in our target value, right? Notice that they're the same. In this case, x is going to be equal to -1. So let's plug in -1 squared. Is just 1. So this ends up being b minus a is equal to 1 minus 2 times -1. This is 2 times -1 is -2. So this ends up being +2 because negative times a negative is positive. Okay? And so b minus a is equal to 3. And again, let's simplify for one of them. So let's move a to the other side. All right? We have one equation. We need one more, right? We need 2 equations to solve for 2 variables. So number 2, let's consider differentiability, or it being differentiable. And so let's set the derivative of the first one, b minus ax squared, equal to the derivative of the second one, 1 minus 2x, right? So again, the derivative is applied to every term in our equations. So in this case, the derivative of b is the derivative of a constant, and that's 0, right? So you have 0 minus the derivative of ax squared. Remember, a is a constant, so you can treat it like a coefficient or a number. So 2 times a is 2a, right? You can leave your x here, subtract 1 from your exponent. This becomes a 1, so I'm just going to leave it like so, okay? The right-hand side, the derivative of 1 is derivative of a constant, which is 0, minus the derivative of 2x, which ends up being 2, right? Because 1 times 2 times x to the 0. X to the 0 is 1. So now we have negative 2ax is equal to -2. Now we can plug in our value for x. X is equal to -1, right? So -2 times -1 is 2, sorry. And now we can solve for a, right? And so a is going to be equal to -1. Now that we solved for a, we can take our value that we know and plug it back into our first equation and solve for b. So b ends up being 3 plus a, which is -1. And so 3 minus 1, because positive and negative, right, is a negative. So 3 minus 1 is 2. And now you solve for a and b, okay? So I hope this helped. And if you got it, then good job. If you need a little more time, go ahead and take your time, okay? If you have any questions or comments, please feel free to leave them below, and I'll get back to you as soon as I can, okay? Have a nice day, everyone.